Are you prepared for what is about to happen? Betelgeuse, a huge red supergiant, the closest to Earth, has experienced a remarkable dimming in recent years, generating mixed emotions around the world. Some speculate that this phenomenon could be a precursor to a supernova, a cataclysmic event that causes concern among scientists and the general public. Betelgeuse, a prominent figure in the constellation Orion, has gained some of its brightness after dimming, but appears to be transitioning to a less active phase. Scientists are concerned about the possible outcome of Betelgeuse's life and whether its eventual explosion could affect Earth. Orion, one of the most recognizable constellations, is known for its two main stars, Rigel and Betelgeuse. Betelgeuse, also called Alpha Orionis, it is the brightest and largest star in Orion. Data collected by NASA's Hubble Space Telescope and other observatories indicate that Betelgeuse underwent a massive mass ejection in 2019, a behavior never before observed in a star of its type. While coronal mass ejections are common in our Sun, this event on Betelgeuse is unique and arouses great interest among astronomers. Betelgeuse corona, however, surprised scientists by ejecting an amount of mass of 400 billion times greater than the average coronal mass ejection, CME. This cloud of hot gas released by the star temporarily covered some of its light, leading to the unusual dimming observed. Although some estimates place Betelgeuse farther away, it could be as close as 724 light-years from Earth. Determining the distances of red supergiant stars like Betelgeuse remains a challenge for astronomy because of its great distance and peculiar characteristics. Betelgeuse is one of the brightest stars in the night sky, being about 100,000 times more luminous than the Sun. However, this intense luminosity comes at a price, as Betelgeuse's immense energy rapidly depletes its fuel, hastening the end of its life. Eventually, the star will run out of fuel and disintegrate under its own weight, possibly giving rise to a supernova and eventually a neutron star or even a black hole if our current theories are accurate. Does Betelgeuse pose a threat to Earth? A supernova outburst a few tenths of light years from our planet would have devastating consequences. When a supernova explodes, it can generate an amount of light equivalent to an entire galaxy, which means that even if the star is relatively close, such as Alpha Centauri, its effects could not be ignored. Since 1604, we have not yet witnessed a supernova in our own galaxy, although in 1987 one occurred in the Large Magellanic Cloud at a distance of 169,000 light-years, with remarkable effects, although it did not pose a direct risk to us. The danger zone around a typical supernova is an intriguing concept that could have serious implications if such an explosion were to occur in our vicinity. However, it is important to keep in mind that, in cosmic terms, nearby supernovae are relatively small events compared to gamma-ray bursts, which are of a completely different scale and much more powerful. Supernovae are bad news. They have the power to destroy biospheres and blanket the world with lethal radiation. A planet's ozone layer can be destroyed by a particular type of supernova years after the explosion, according to a recent study that adds a new potential danger. Giant stars can briefly reach some of the highest luminosities in the universe when they explode in a large explosion known as supernovae. The brightness of hundreds of billions of stars combined can be eclipsed by a single supernova. Will the Earth be destroyed by a Betelgeuse supernova? The star will be the second brightest object in our sky after the Sun when the supernova occurs, despite being away from us. Betelgeuse, which shines brighter than a full moon, will be visible during the day. It will be so dazzling for a few weeks at the peak of the explosion that shadows will even be cast in pitch darkness. Despite its terrifying brilliance, the visible light emission from a supernova constitutes only a small amount of its total energy output. Furthermore, Although exposure to high levels of visible light can result in blindness, it generally does not have many other detrimental impacts. The high energy radiation associated with the supernova, which generally takes the form of X-rays and gamma rays, is more of a concern. This high energy radiation has the ability to catalyze the removal of oxygen from the ozone layer that protects the Earth. Without the ozone layer, life on Earth's surface would be exposed to the full force of the sun's ultraviolet radiation, which could result in an extinction event in the first few seconds of a supernova. After the initial outburst of radiation, a greater threat emerges over time. Eventually, hundreds or millions of years later, cosmic rays, which are subatomic particles accelerated to nearby the speed of light, emerge from the maelstrom. They can also shatter ozone layers and blanket the planet's surface with deadly radiation, in addition to carrying with them a considerable part of the total energy of the supernova. Such events could have occurred in the past. Significant levels of iron-60, a radioactive isotope of iron created in the supernovae, are found in cores of the seafloor and lunar regolith. According to the analysis, iron-60 is a sign that the Earth was recently hit by a supernova ejector, possibly within the last few million years. Astronomers have previously determined that we are fairly certain there are no close supernova candidates that could endanger life on Earth based on the dangers posed by gamma rays and cosmic rays. But astronomers have discovered an additional possible risk. A specific type of supernova has the potential to emit deadly radiation that is additional, long-range, and dangerous to worlds like Earth. When a star nearing the end of its life is surrounded by a substantial disk of material, a specific kind of supernova arises. A shockwave is generated after the initial explosion of the supernova and strikes that disk. This shockwave causes the disk to become extremely hot, which in turn leads to the disk to generate a large amount of X-ray radiation. This radiation has a high energy density and a very long travel range. The brightest X-ray supernovae can overload a planet's ozone layer, depleting it by as much as 50%, which is more than enough to trigger an extinction event within a staggering 150 light-years radius. Such supernovae would deliver a lethal blow. A fragile planet would be bombarded by X-ray months and years after the initial outburst. Then, cosmic rays would arrive hundreds of thousands of years later and complete the task before the biosphere had time to recover and replace its protected shell. Fortunately, no candidate X-ray supernovae have been found to be close to Earth, but the galactic habitable zone, the area in each galaxy where life can exist, is now subject to additional constraints as a result of this research. Star formation is insufficiently high in the outermost regions of a galaxy to produce the elements needed to generate rocky planets. However, dense star centers, where stars live and die rapidly, are equally dangerous because frequent supernovae irradiate the surrounding area. According to the new research, it is likely that the inner boundary of the galactic habitable zone is located farther away from the galaxy's core than previously thought. What will Betelgeuse supernova explosion look like from Earth? Earth biospheres will be unaffected, but that doesn't guarantee that no one will notice. According to Goldberg and Bolger, Betelgeuse will shine more than 3 months after its explosion with a luminosity comparable to that half of the Moon, 9 times fainter than the full Moon. A single point would contain all its luminosity, so it would look like a very bright beacon in the sky that could be seen during the day and cast shadows at night. It will be inevitable, and everyone on the planet will be fascinated by it. The supernova would be visible to people in the sky during the day for about a year, and as the supernova remnants fades, it will be visible to the naked eye for several years. If you liked the video, remember to like and subscribe, and I'll see you in the next one.